And there's not anything to solve, you're just literally writing down what we learned yesterday. It's Raffle Friday, which means we've got prizes up for grabs this week. Raffle Friday is, usually, you know, I've done those folder things where you got like James mystery prizes behind. Our mystery prizes are located in these 3 buckets. So you'll tell me the black one over here, the white one in the middle, or the black one over here. And if you win, well, there will be 3 winners, and they'll get whatever is in the bucket. So, Jesus, sign is equal to what? Correct. Do you have a triangle here, though? Sure, you can make one. Make a triangle. But just in general, think of your identities on your flashcards. Yeah. So we did write B over C, but what is it compared to like the reciprocal, the opposite of one of the functions? Do you remember which one it's the opposite of? Sine and...
Oh no.
You're close. Josh?
I put 1 over cosecant.
It's the opposite of cosecant. So whatever cosecant is, we flip it. Which we wrote like whatever it was, you said B over C, and then we said C over B. We went back and forth. See what I mean now? Okay. So Josh, pick someone else for cosine. Like 5 seconds. Adrian. 1 over secant, and pick one more person for tangent. 1 over cotangent, also known as cot. And then these 3 are just going back the other way. So 1 over cosine, 1 over sine, 1 over tangent. Branda, call on someone though to give us the quotient identity. The first one for tan. Sine over cosine. Good. And one more.
Cosine over sine.
Then we flip it and cosine over sine. So if you noticed, to look at these, you were flipping back to your notes from yesterday or looking at your flashcards, then good job, way to use your resources. But we also want to be moving towards, like a lot of us probably know that sine and cosecant are opposites, and so that should be one that we also kind of have memorized. So if I do another do first like this, I want you to try to do it without looking. I mean, you with me? Do it without looking. I want you to have these memorized. Today, you're going to notice, I don't know if you and all your friends talk about pre-cal and they've told you about the lesson already, but today's lesson, we're going to be moving away from yesterday when we were doing problems with numbers where I said sine is 4 over 5 and y'all said cosecant is 5 over 4. And we're going to be all in the land of just sines and cosines and tangents where we are trying to manipulate those things and prove or simplify what those things could like cancel out and equal without any numbers, just like rewriting things with sines and cosines and tangents. And for some of us, it's definitely going to be a little bit like uncomfortable, and the problems are going to seem like really, really difficult. Like, how would I ever know to use that identity that she just used right there? So my goal for y'all is to try to just like stick with me as much as you can through these examples and try to catch yourself. I know it's 8th period, but anytime you're just writing down what I'm writing down, just for the heck of it, make sure you're really understanding what you're writing, or when you go to do one of these on your own, like this is going to be definitely a difficult task to do. And we're going to practice more on Monday and Tuesday, so even if you don't even get through one problem today on your own, you need me to like jump in and help you, that's okay. The goal is like by Tuesday for you to do like one of these proofs all the way through, okay? So let's take a look and see what we can come up with. We are going to be referring to the identities on your flashcards so you can have them out and be looking up things as you need to know what tangent equals. You can look for tangent and look at the other side and see what you can use. You can also flip back to your notes if you'd rather just look at the boxes from yesterday. Who in here now has their flashcards cut out? My wonderful students that have them cut out. Wow, thank you for being so wonderful. Those of you that don't,
Be ashamed. Be ashamed.
I don't even want to know at this point. I'm so disappointed in you. So, like it says, anyone else, dot, dot, dot. Please cut out. If you need more copies, I have more copies. Alondra wasn't here, so she doesn't have a cutout, but that's not her fault. We're going to get you some copies for you. Alright, we're going to jump in to the first problem. Like I said, when I'm going through this, the goal is not just like the answer, it's more about the process of like what questions was I'm gonna kind of talk through like what my brain is thinking of as I'm going through this. What questions did I ask myself as I went through? Because those are the questions you're gonna need to ask yourself when you go through to figure out what identity you need to use, okay? So here's what it says. It says simplify. Oh, that's not gonna work. You're not gonna be able to follow along. If we're like, yeah, you're with me? Okay. It says simplify secant minus tangent times sine. By simplify, that means similarly to when we've seen earlier in math, when it said simplify like 2/4 and y'all made that into 1/2. We're finding something that's equivalent. Those are still the same, right? But is more simple. And in that case, that meant like the numbers are smaller in the numerator and the denominator. For us, that's going to mean we're going to try to go from secant, tangent, and sine and see if we can like condense or put together or cancel out so that we can get something much more simple. And the answer is not as much what I'm worried about, so I'm going to go ahead and actually for this one give you a preview of what the answer is to see what I mean by simplify. The process is what's going to take a while and take some time to figure out how to do. So, for example, this, when all is said and done, we're going to end up to be able to show that this is equal to cosine of x. Much more simple, right? So that's what I mean by simplify. But how do I get there? That's going to be the process that we're going to kind of learn today. So let's take a look. I got secant minus tangent times sine. I know that secant, tangent, and sine are all equal to a bunch of other things on our flashcards from the identities we've already learned, correct? So let's think of which ones we're going to use and which ones aren't going to help us. So for secant, let's just start brainstorming. We know that secant is equal to 1 over cosine. So the more that is just something you know, the easier these are going to be. That's 1 over cosine. For tangent, I've actually got a couple options. Raise your hand if you can tell me one option for tangent. Maggie?
Sine x over cosine y.
Okay, so, sorry, for this one we said 1 over cosine. Here we said sine over cosine. Interesting, okay. Can someone give me tangent? There's a couple. What's another option I can do for tangent? Adrian? 1 over cotangent. And then sine, you could do like 1 over cosecant. All of those things are floating around in my head when I'm looking at this. And we're trying to pick which of these are going to help us to where we can start like putting things together and simplifying, okay? So if I, for example, say secant is 1 over cosine minus, and now I go to rewrite tangent, I've got a choice. So raise your hand now that you see kind of like all this stuff floating in my head, if you can tell me which of these you think you would pick for tangent, because we got an option. Which of those makes maybe more sense for us to pick for tangent in this case? Juan? Sine over cosine? Why would you say that? I would agree. Common denominator. See how these have the same denominator? So if we can match that, cotangent's going to be like another random one we're going to be throwing in the mix. So let's actually, I'm just going to like not use that for now. I'm going to say tangent is sine over cosine. Good thought. Times, and then the other thing is don't automatically jump to changing everything. I could write sine as 1 over cosecant, but I could also just leave it as sine. And if I leave it, then I'm not going to get a cosecant here on the bottom. If I get cosecant on the bottom, then this is no longer going to match, right? I'm not going to have cosine and cosine. Now I'm going to have cosine and cosecant.
What?
Let me show you. You don't have to write this, but if I change this, now I have cosine over here, and do I have just cosine over here? No. But if I leave it as sine, when I'm multiplying times sine, that sine is not on the bottom, it's actually on the top, because this is like sine over 1, right? And so I have 1 over cosine minus, and on the bottom here I still have cosine times 1 is cosine. I still have the same denominator. So you don't, again, have to. You could change it to cosecant, but then you've got to find a common denominator now with cosecant on the bottom, and so you're kind of adding things in that you might want to avoid, okay? So we end up with, on the top, sine times sine, right, which is, you could write as sine squared. With me so far? Okay, so we've got a common denominator of cosine because not only did we just write random trig identities, we chose trig identities wisely that are going to help us to have a common denominator. Okay? Then, now that I have a common denominator, I can just put the two together and say I got one cosine over here, I got sine squared cosines over here. So if I put those together, how many cosines would I have? I'd have 1 minus sine squared cosines. The top, you're just going to combine. Just like you have 2/6 minus 1/6, you just subtract the tops, right? We just can't actually subtract those. Okay, so if you're looking at that at this point, because it's the first problem that you're seeing, y'all probably are like, I don't know how that's really helping us to get here because this still looks pretty complicated. I now have like squared things, but at least we have condensed into like one fraction, and we're going to hopefully get to cancel some things out and get to cosine here in a second. Okay, now when we see things start to become squared, not always, but a lot of the times, my mind is now jumping away from my reciprocal and my quotient identities that we wrote in the do first, and we actually learned 3 other ones yesterday at the end of class, right? And if you remember, all of them had things that were squared. We had sine squared plus cosine squared equals 1, right? You should have a flashcard that says that. 1 plus tangent squared. I like tangerine. Anyone remember? Cosecant. Not quite. Tangerine sections means secant. So that'll help you hopefully remember which one's which. And then I like cottage cheese. So cheese is going to be the cosecant to help you remember that one. Okay? So when we look at those, and I look at this, on the top I have 1 minus sine squared, which I don't see sine squared in either of these, but I see something along the lines of this one up at the top, but it looks a little different, right? But I got a sine squared and I got a 1. This has got a sine squared and a 1, so we can maybe like rearrange it to kind of help us out, okay? So any of these 3 that we used yesterday, we need to know, using algebra, I could rearrange any of them at any time, right? So for example, right here, I could subtract sine squared from this side and this side, correct? On this side it would cancel out and I would just be left with cosine squared. And on this side I would have 1 minus sine squared. So notice this identity rearranged is, I could also say that cosine squared is always going to equal 1 minus sine squared. And that's what we have here in our problem. We have 1 minus sine squared. So what is that always equal to? Cosine squared. So the top we can rewrite, and I wouldn't expect y'all to necessarily make that leap right now, but you'll start to see this a lot and you'll be able to recognize that. You can write that 1 minus sine squared is equal to cosine squared, and then we left the bottom the same. We didn't do anything to the bottom yet. Okay? Some of you guys are already going to see if I have a cosine on the top and a cosine on the bottom. They're going to cancel. However, let me kind of break it apart to make it a little more obvious for some of y'all. Cosine squared is like having cosine times cosine, right? And so only one of them is going to cancel, which means I'm left with 1 cosine left, and that's how I'm going to get all the way to cosine. Okay? So I made, let me summarize really quick, then I'm going to take your question. I chose wisely to try to find things that in general would give me like not just random other trig functions, but hopefully something in common, like a common denominator. I put those 2 fractions together, and then because I noticed that this was a sine squared, I was thinking, I know that there's a sine squared in my Pythagorean identities, and I was able to do some rearranging to substitute that for cosine squared and cancel. Joanna, question? I didn't mean to. The other day in class though, like Angie was kind of giggling and I was like, are you okay? And she was like, yeah, you're fine. And then like I went to the bathroom later and I had like blue pen all over my face. And I was like, Angie, you didn't tell me. She's like, I know, I felt bad telling you. I was walking around all class. I think I had it on my hand and like itched my face and it was like all right here. Well, it wasn't just Angie, no one told me. So thank you. Do I have like glitter? Or just like, oh jeez. I don't know where that came from. Well, hopefully the snacks. I'm having an interesting hair day, so we got a lot of things going on. Okay, so if y'all can follow those steps, then hopefully we feel okay. The goal now is, can we start the process on our own? But again, I'll make like kind of the same disclaimer. I do not want y'all to leave here like frustrated when we go do a problem right now and you're like, oh my gosh, I'm stuck. So the goal today is to try to start experimenting with plugging in some identities to see what you can get to cancel like as a team at your table. And then I'll be able to like jump in today and kind of help you get to the end result so that hopefully by like Tuesday next week you could do a whole one on your own, okay? So I'm actually gonna ask you for the next one. It's kind of a whole different beast, a whole different animal. So I'm gonna ask you to skip that one. We're gonna come back and kind of model that together. But if you flip the page, the one on the top of the next page is the same type as this one, where we've got 3 trig functions with subtraction. And they're completely different trig functions, so you're going to use different identities, but a sort of similar process to kind of go through this one. Because the answer is not what I'm worried about, I'm going to go ahead and even tell you where you're going to end up like I did with the last one, so that you know if anyone in here manages to do it. That's the challenge. We'll see if we get anyone. You can make this all the way down to tangent. So that's the goal. But I want you to get as far as you can, working towards it together, and then we'll see where we get. But you can get to tangent. Yeah, same thing. Theta and x are just like, a lot of times they use Greek letters for angles instead of x, but it's just a number we don't know. It's the angle. Okay? Try it out. I'll be around to help. Talk to each other, give each other signatures. These are subtracted, these two are multiplied. When they're next to each other, it's multiplication. What do you mean? Like, tell me, like, with what here? The reason I did that is because so I had to write that here. I couldn't write the 1 over cosine over here because that's what's equal to. And because of that, when I was using tangent, I didn't use this because then I would have had a tangent on the bottom and those would be different. I chose sine over cosine, and then that'll match there. This is multiplication. So let's maybe, so let's think. If this is 1 over, what is this? Let's brainstorm first.
Actually, I think we should.
There's only one for this. Okay. And then what's okay. And then cotangent, you can pick which one. So our options here are sine and cosine on the bottom. And then for cotangent, we've got 1 over tangent. We can also do cosine. Because you just told me that these ones are going to be sines and cosine. Okay. So try, you can rewrite both of those if you want. You can kind of pick and choose one. It depends on what strategy you're taking, but I don't want to put it away. And then for this one, let's probably do like you said, the cosine over sine. Okay, so you chose 1 over tangent, right, for this one. And both our Jesus decided not to use 1 over tangent. He decided to use cosine over sine because if he uses this one for cotangent, you could use either. But if we use this one, then we have a sine over So that one you can only choose either. Leave it as a secant, don't change it. Or if you change it, and you're just going to have to figure out what you cosine over here as well. So make that. Oh, there's 2 So let's try it. Okay, now we can just kind of jump in. 1 over sine times over cosine. Cosine over sine. Okay. So let's take, you want to multiply these together. We get 1 over sine
Divide by 2 is 1.
minus, and over here we got cosine over sine. So to get a common denominator, it's not too far off. We're just using this to have a cosine, right? So multiply that cosine on the top and the bottom. Cool?
I don't think I have to change it,
Okay, how did you get this? Okay, so you wrote these, but then you recanceled these.
It's weird because I never do that when I get it. To me, it's like, she didn't call us software.
So now let's combine. So you got your denominator, sine, cosine. So when we saw squared, it was different, but it's similar. Remember I saw 1 minus sine squared? Do you remember what I said my brain was doing? Now I showed looking at my identities, and if you look at these three over there, they're the ones that have all like the square roots. So see if you can figure out what 1 minus sine we said was equal to cosine squared. See if you can figure out what 1 minus cosine squared would equal.
Basically, you know how it's flipped? Like, cosine?
So you know, talk about it. Sine squared equals 1 minus cosine. How are we doing on the can? You need to
Take the other one.
Hey, good. Okay, so then you multiply those, you get 1 over sine cosine
Oh my god.
minus cosine over sine. Okay, so now if you want to go put these fractions together, just like here we put these fractions together, remember this is nice to be a cosine and cosine. Here, close, because we have sine and cosine. They doesn't match, so this is how it cosine. So to get a cosine on the bottom, I would actually take the cosine on the bottom and multiply this cosine on the top. Right, like if I multiply this cosine on the bottom. So now you're there. If I want this cosine, I gotta put it up here, so you gotta put it
Now what? How do you get rid of it? How do you get rid of it?
So they don't cancel. What happens is you can put them together. See how like
They do.
and now they're writing 2 sec for expression.
What's different? What's different?
Just like you have 2 sec. Now go over there and see if we figure out what we can rewrite it. It's a little bit different than the last one, but you're gonna have to remember that. Okay, 1 over sine times 1 over cosine over cosine over sine. Love it. I like that you chose to use cosine over sine rather than over tangent, because I see sine equal these, so we're close. Okay? So then, I noticed Jonathan went and actually like multiplied these. So if we want to now add or subtract these fractions, you would need the denominators to be the same. Like in the last one, we had cosine on the bottom of both of them, so that we could subtract. So let's think. We're close, because this has a sine and this has a sine. But but I noticed right here you wanted to put a cosine right here so it matched, right? You can do that as long as you multiply times cosine not only on the bottom, but also on the top. So you multiply times cosine on the top and bottom. On the top and the bottom. So not just one cosine, you gotta multiply it on the top and the bottom. Because now that's equal to 1, so like I'm not sure. Whenever you have cosine times cosine, like do like one of these said, that's cosine squared, like x times x is squared. So whenever I multiply times cosine on the bottom, to get it to match this one, you can't just change the bottom. Whenever I have a function like 1/2, if I want this to be like times 2 is fourths, I would have to do times 2, let's say 3/4, right? Because what do it normally to match. And if I do it on the bottom, I gotta do it on the top. So, top and bottom, cosine squared. I'm gonna let you walk to them. And then they can give you 2 participations. Yes, ma'am. You did it?
I did.
Wait. Josh, did you get it? No. Can one of y'all assist my man Josh over there? There's too many people in here for me to help out. Okay, so you went a slightly different route than they did over here. We need to put there because I've seen some people because y'all noticed, like in the last one, you didn't want to change the line. So this gets a little bit messier because we want to take like the things super obvious and you can do I'll kind of run you through it so you see it. And then I'm actually the people that did me this as one cosine. What I would do here is, because this is cosine, I'm just going to start here and change that to cosine. It's not exactly cosine, but we can change it to right? Now, I see a fraction again, and in order to subtract, I would delete that common denominator, and this doesn't even have a sign. So let's think, if I wanted this to have a cosine on the bottom, every time I multiply on the bottom, I can multiply over the top too. So if I have cosine on the bottom, I need another cosine on the top, okay? So now I have 1 minus cosine squared over cosine, right? If I put those together, and I'm going to kind of do this in one step because y'all can do it. Then I'm going to trig divided by sine. So I have a fraction with division, so you can flip it and change this division to multiplication. Instead of sine over 1, I can rewrite it as, yeah, okay. And then 1 minus cosine squared is going to be a rearrange of this one. Subtract cosine over it.
Okay. So, because in order to subtract this, you gotta have the same denominator. So what you're gonna do is multiply by cosine times cosine times cosine equals cosine.
But one side would cancel, and then you'll put the one side on top of
minus
on top of 1 minus cosine squared is equal to rearrange by top of cosine squared equals this is
get closer to
So like I would not write it. I would write in the place of this, like right there. Like my next line right here. Instead of on the top writing 1 minus 1 squared, I'm gonna write it as sine squared because I know those are equivalent. Right, like it's like me saying like this and like this, so I can write it as this. I'm gonna write it down.
Because sine squared equals this.
Sine squared times
I know that sometimes when you like online, you can so part of it's also to stay. Where am I? Okay, I'm gonna read back. Okay, if I can get y'all to turn your voices up, the more examples you see of this, the better. Okay, so some people kind of went some different routes on this. I'm going to steal Joanna's paper. It's okay. I'll walk up through it. And I'm going to just use this so that y'all can check in case some of y'all, I didn't get obviously to every table, so I assume there's some tables that didn't get all the way to tangent, which is fine. Just for a quick show of hands, so that I do know for like purposes of how much in depth to go over this. And raise your hand if your table did get to tangent and you feel good about this simplifying. Okay, cool. All right, hands down. If not, no worries. Sometimes it's as quick as if one person at your table's got it, and then they just kind of like share with everyone else, and that's why their whole table ended up having it. So let's talk about this one. This. Up at the top, I got some quick notes right here that she wrote that cosecant is 1 over sine, secant's 1 over cosine, and then she's got this choice for cotangent. And she chose, which I saw a lot of y'all, use cosine over sine so that it was similar to these guys, right? Okay, so then next line, we've got 1 over sine times 1 over cosine, because this is cosecant, this is secant, minus, and this is our cotangent, cosine over sine. We get to that point? Okay. Then we noticed, okay, if I multiply these two together, I get 1 on the top, because 1 times 1 is 1, and I get sine times cosine on the bottom. And I've got my cosine over sine over here. These are not a common denominator right now, right? So what Joanna did is she, on this side, said, ooh, I need a cosine on the bottom. Okay, I can't just put it on the bottom, but I can multiply times cosine on the bottom as long as I do it on the top as well. So then she multiplied times cosine on the top and the bottom here, so that the bottom said sine cosine here, and it says sine cosine here. Common denominator, right? So, over to here, she has on the top 1 minus, and cosine times cosine is cosine squared, agreed? And on the bottom, she's got her common denominator, sine times cosine. Any questions so far? Okay. Then, this is similar to what we did in the previous one, but a little bit different because it's cosine instead of sine. This numerator is a rearrange of this Pythagorean identity. So all we need to do is subtract our cosine squared over this time instead of our sine squared, and you can see that that numerator is equivalent to sine squared. Sine squared is equal to 1 minus cosine squared. Therefore, she jumped over here. I like the order. We got sine squared on the top and a sine times a cosine on the bottom. Okay? If we have that, then we have 2 sines on the top and 1 sine on the bottom. I'm just going to break it up for anyone that needs to see it. Oh. Didn't mean to do that. And what can I do with the sines? Oh my gosh, that's so weird. So then we get sine over cosine, which is what she has up here. I just wanted to show you where she got that and what sine over cosine equal to. Tangent.
Man, this is confusing.
Yeah.
Like, you have to get to one answer, and there's so many routes to go.
So many routes.
Yeah.
Which road to take? Isn't there a poem about this? Take the road less traveled, or whatever. Robert Frost. I don't know. Can someone turn the light on? Maggie? Oh, when Carmen comes back. Okay. But, just as a side note, back at Maggie and Leslie's table, they actually kept this as secant. They did not change it. They kept it as secant. Any other tables keep it as secant? Okay, and it is possible. Did you get there, Mon, to tangent from that route? But did you end up getting there? Okay, so it's possible. They kind of got stuck and I kind of helped them out and we eventually got there. But you can actually keep it as secant as well and get there that way. So there's actually multiple ways for us to solve most of these problems, which gets a little crazy. Okay, so we got 10 minutes left, which means we can go back to this kind of beast of a problem, and now let's spend the last 10 minutes. In some of my classes, we kind of like people needed me to slow down and I didn't even get through it, but I assume with 10 minutes we'll probably talk through this entire example, and then on Monday just get to practice more ones like it, okay? So when we look at this one, this is kind of like a whole different situation because not only do we have subtraction, but we have numerators and denominators already and all sorts of crazy things going on. So, when we look at this, anyone before we start just have any ideas so I can give some like tickets and stuff? And you'll in the last class, I'm gonna just like be honest, I had like 5 ideas, which was awesome. But then we actually talked about algebraically whether we could do them, and like I had to shoot down all the ideas because they didn't work. But I still appreciate y'all trying things out. So, Jose, what do you think?
Can we change for the denominator of the first one to squared, cosine squared?
I was hoping you'd say that because you can't, but I want to talk about why. So let's see. The P says 1 minus sine x. We've had this suggestion in most classes, so that's why I want to like kind of clear this up. A lot of us, now that we saw in the last example, 1 minus sine squared, and we changed it to cosine squared, a lot of us want to change this one. But can we change this? We don't have an identity that says this equals cosine squared or that it equals cosine. We can't like just take away the squares. So unfortunately, it looks similar. So usually I'd say like if it looks similar, like maybe that's a good thing. But in this case, algebraically that wouldn't be equivalent, so we can't take that part out right now. Any other thoughts? Yep. Okay. Perfect. So I would end up, when I see fractions, you'll start to see this happen over and over and over, and that's what we're going to probably end up doing, is right now they don't have the same denominator, and so one good thing to do first when you see problems like this is to go ahead and start making a common denominator, okay? In this case, it's not as easy as that last one, where we just multiplied one of them times cosine on the top and the bottom, right? In order to find a common denominator with this one, it's kind of like when you see 1/2 and 1/3, you would use 1/6, or not 1/6, but you'd use 6 because you can multiply 2 times 3 and you can always use that as a common denominator. So what we're going to use as our common denominator is 1 minus sine x times cosine x. We're going to multiply the two together, and that's going to be the denominator that we now write for both of these. Okay? So let's think about that. For this first fraction, that means we had to multiply this times what? Cosine x. So we got to multiply times cosine on not just the bottom, but the bottom and the top. So on the top we now have sine x times cosine is cosine squared x. With me so far? Over here, I've got cosine, which means I've got to multiply times 1 minus sine x to get it to match this one, right? So I got to multiply times 1 minus sine x on the bottom, but if I multiply on the bottom, I got to multiply on top. Okay. Madness. But one day when you do one of these, you can frame it, show all your friends how good you are at pre-cal, and everyone's going to be really impressed. Okay, let's keep going. Some of y'all are like, what the? But we have a common denominator, so we can put them together, right? Or you got a comment first?
I was going to say, can you simplify the 1 plus sine x and 1 minus sine x to like the subtraction of squared? I forget what it's called.
On Tuesday, y'all remember when we did these? Difference of squares? I didn't do it just randomly. Remember I said that anytime we have same thing, anytime we have the same thing but opposite signs, stick with me, anytime it's the same thing but opposite signs, like technically the strategy y'all know to solve those is to like do your box, but I taught y'all to like save us some time because these are already like beasts of a problem, is we should know that these middle terms are going to cancel out, and we saw that things like this end up being just the first thing squared and the second thing squared. No, that's wrong. 2 squared is 4, and since it's positive and negative, it would be a minus. So she says, let's go ahead and just do that for the top right now. So let me circle it to show y'all what I'm talking about. This is just opposites, right? So we can say that this is going to be equivalent to 1, because that's 1 times 1 is 1. And then positive sign times a minus sign is a minus sine squared x. If these were not plus and minus, we would have to like do a box there because we would need not only these two but the middle terms as well. But since it's a difference of squares, you're good to go. Okay? Now with that, I can go ahead and I don't want to skip too many steps, so let me just write it all down again. 1 minus sine x cosine x. Really fast because we're nearly done. Yeah? Okay. Now I can put them together because I've got common denominators. So I can just rewrite this with cosine x 1 minus sine x on the bottom. And I can go ahead and subtract everything on the top, right? Okay. Before I do that, I'm going to write this one. Sine x cosine squared x minus, but let's think about what this top again would be equivalent to. We've now seen this, Jose. At the beginning you said, can we change 1 minus sine? And I said, no, I apologize, you cannot. But can I change 1 minus sine squared? Since it's squared, 1 minus sine squared we said is equal to cosine squared. So I can now say, let me circle it, that this part, I'm just going to rewrite it as a cosine squared. Okay? I wish, but it's subtraction. Not yet. Okay, 3 minutes. I don't know if we're going to finish this one because I want to choose my raffle tickets. But the direction that we're going to go is, see how there's a cosine squared in both of these? So we also did those problems on Tuesday where I asked y'all if, for example, 2x plus 2y, we said that that's equal to 2 times x plus y, right? Like you can pull out the 2 and do the opposite of distributing. So I can pull out a cosine squared. See how there's a cosine squared in both? And what's left for this first term? Sine x minus, if I pulled out cosine squared x, it's just a 1 right here. Let's check. Sine cosine squared minus cosine x. I pulled out a cosine of both of them. Let's check. If I multiply it back in, just distribute this, y'all. This is the same thing as this. Okay. Whatever I said that time, that worked. Okay. 1 minus sine x. Okay, now your cosine, one of them can cancel. Because this is multiplication. Okay. So we have a cosine left on top, a sine x minus 1, and on the bottom, I got a 1 minus sine x. It is super tempting to cancel these, right? And we're super close because we know our answer is cosine, because I've told you what the answer is. But the issue with these being opposites, this being negative sign and this being a positive 1, is where this negative is going to come from. One of this is, we can cancel, but one is the opposite of the other, so I'm left with a negative. I can basically take out a negative. I'll go over this on Monday. I can take out a negative and make this negative and make this positive. Like, again, take out a negative and a positive, and these will cancel, and I have my negative. Magic! Okay, no stand up, because I want to raffle, and I can't. Okay. And then you look really smart. Okay. 4, 6, 2, 5, 3, 5. Come on now, which one do you want? 1, 2, or 3? Ooh, a kitty. 4, 6, 2, 5, 2, 0. Okay, which one? Hey, sit down, I can't hear.
Yeah, that's a new one.
Do you get? Ooh, a pretty good pass from the computational